Good morning and welcome to Global Earth Watch. I'm Tristan Langer and tonight we're taking a closer look at the unstoppable forces of erosion that constantly remodel Earth's surface. From the steepest mountains to the vast deserts, these agents, gravity, waves, and wind, are nature's sculptors. We have 3 field correspondents standing by to report their effects. I hope our reports are totally rock solid. We'll start with the fundamental force that pulls everything down, gravity.
Thanks, Tristan. I'm Ben, reporting live from a hillside where the evidence of mass wasting is clear. Mass wasting is the term for downhill movements of rock and soil, and it is entirely caused by gravity. I normally don't like talking about gravity, it really brings me down. The most dramatic events, like a landslide or rockfall, are often triggered by a mix of factors. Steep slopes, especially in a dry or semi-arid climates, and a sudden shock like an earthquake. But the real catalyst is often water. High saturation levels dramatically increase the likelihood of mass wasting because water adds considerable weight and reduces the material's internal hold or friction. We see 2 main speeds of movement. Slow mass wasting, or creep, is a gradual continuous movement down a slope, often in wetter environments. Rapid mass wasting, like landslides, is fast and involves mostly rocks and debris. Isaac Newton, gravity exists. Warning signs that a slope is unstable includes finding cracks in the ground, unnatural bulges, the tilting of structures, and old landslide scars. Unfortunately, humans often increase the risk. Construction can destabilize the ground through digging and adding weight, and deforestation destroys the vital root systems that provide stability. Over time, mass wasting creates new landforms, altering the shape of mountains and valleys. The first real-world example is slumps. The Longchita landslide in California is a devastating example of a slump, where heavy rainfall saturated the coastal bluff, causing a large rotational chunk of the landslide to fall. The second example is creeps, which result in the tilted trees, like those found on gentle hillsides, famous in Pisa, Italy, where the slow pull of gravity on wet soil gradually tilts them over many years. Back to you, Tristan.
Okay. A sobering look at gravity's power. Now we move to the coast to see how water interacts with the land. Here is Will Pascal on the dynamic shore.
Will Pascal reporting for duty. Tristan, the ocean waves are tireless sculptures. Wave erosion occurs as waves carry and deposit sediment along the shores, either pulling it back out or moving it along the beach.
Yeah.
The strength of the coastal erosion is dictated by natural factors like wind, which generates waves, storms, which increase wave strength, and tides, which are caused by the moon's gravitational pull and change where the waves hit. The ocean is always busy working. I guess you could say it's always tidying up the coast. A key process is the longshore current, which approaches the shore at an angle and moves sediment in a constant zigzag pattern. Out here, the sand never stays in one place. It's all over the place. I guess you could say this beach is a little unstable. Some coastlines erode faster than others due to different rock types, varying wave strength, and storm frequency. This erosion This erosion presents major problems, destroying coastal ecosystems like coral reefs and threatening human settlements with storm surge. You know why the ocean waves are so salty, right? Because they land never lets them finish a joke. But seriously, what did the sea say to the sailor? Nothing. It just waves. There's 2 landforms that are formed by wave erosion. First, there are the barrier islands, like the Outer Banks of North Carolina, formed by waves and currents depositing massive amounts of sand parallel to the shore. And there are spits, such as Sandy Hook in New Jersey, which is a long ridge of sand that extends from the coastline, created by longshore drift, slowing down and depositing its sediment load. Finally, an interesting fact. Some powerful waves from major storms can carry thousands of tons of material. Back to you, Tristan.
The sea's power is very immense. Now we look to a force that is often overlooked, yet one that has shaped some of Earth's most iconic landscapes: wind.
Thank you, Tristan. Wind erosion is most common in dry or desert environments because they lack the water and vegetation that hold soil together in humid areas. I was going to tell you a joke about wind. Together in humid areas. I was going to tell you a joke about wind, but it kind of blows. Wind moves sediments based on its size and weight. Smaller, lighter particles are moved more easily and faster. This movement is what causes sand dunes to migrate over time. As wind constantly pushes sand up one side and over the crest, vegetation is key to prevention, as its roots hold soil in place and the plants themselves block wind. A good joke about wind erosion should really blow you away. Wind has famously shaped landscape like Monument Valley, wearing away softer rock layers to leave behind the towering, unique formations we see today. Unfortunately, human actions like overgrazing or excessive farming remove vegetation and disturb the soil, making it easier for wind to take hold. Here are two landforms and real-world examples. Sand dunes. The massive dunes of the Sahara Desert in Africa are formed by strong winds piling up loose sand into massive dunes. Desert pavement. Though we also see Loess deposits, fine dust/silt blown and deposited by wind, like in China's Loess Plateau. Wind erosion is responsible for White Sand National Park in New Mexico, USA, where wind moves and shapes white, just sand into dunes. And a cool fact, desert varnish, a dark coating on rocks, is caused by wind erosion, and it's how many ancient people created hieroglyphs. Did you hear about the land that was affected by wind erosion? It was an absolute disgust.
Thank you to all of our field correspondents for those excellent reports on the effects of gravity, waves, and wind. As we conclude tonight, let's reflect on the immense power of these forces. While all are constantly at work, one might argue that gravity is the most powerful agent. Why? Because it is a fundamental force that enables and intensifies the others. Mass wasting or the sudden failure of a slope is directly caused by gravity. But gravity also causes tides for the waves and is the reason sediment moves in a predictable downhill direction for both water and wind erosion. The impact of erosion on people and communities is immense. We saw how it can be devastating. From the rapid destruction of homes caused by a slump like the La Conchita landslide and the gradual loss of coastal land that threatens habitats and forces communities to build expensive seawalls and groins. Erosion affects food security by moving topsoil and changing our access to land. Finally, one new thing that I learned tonight is the effects of gravity extend far beyond just pulling objects down. Gravity's power is so profound that it can even bend light and affect the flow of time. That's all the time we have today, and I'd like to thank you all for watching Global Earth's Watch. Good night.